I'm just moving things around on my desk. That wasn't supposed to happen. There it is. What is that? Oh. Mute here for a second. All right, I turn the live transcript on. I'm still setting up my computer here, so I won't have to rush and run so much to get things set up during class. Although classes technically began a minute ago. Oh, we didn't finish section 6.2, did we?
I don't believe so, sir.
Did we talk about the symmetry aspect? Or I know I did, but did we cover that in the slides?
No, I don't think so, sir.
Oh, okay. So we'll start with that because I think everything else we've kind of covered in this. Oh yeah, we dealt with the rain gutter problem, constructing a rain gutter. So all right, I'm just about ready to go. Boom. And all right, what I want to do right now is talk a little bit about, oops, wrong place. I want to talk a little bit about MyLab. MyLab is extremely important for this course. That's not it. There it is. And, uh-oh, that's not what I wanted. Again, that's not what I wanted. That's not what I was going to. That shows my open file. PowerPoint slide, show all windows. Yeah. There we go. Well, I don't know what's going on there. So let me go over here. And maybe it'll do it now. Oh, I had, there it is. Okay. So for those of you who have not gotten full access or the temporary access, you have to go and try the modules first and see if Red Shelf is working for you so you can get the passcode. And so this shows up, you click on this class, the book for this class, and you copy the code. Okay, and then you go to MyLab. If you can get the code, great. You can go there and then you open up the MyLab and you put in the access code. And then you build your account. If Red Shelf isn't working for you, you still go into MyLab and you get the temporary access code. I mean, the temporary access. Um, 'cause, 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 ' So if whether or not, well, if you can't get the red shelf access, because everybody gets their own access code. It's not like we used to do it where all of pre-calculus has one code, because that's how it used to be. All of the math classes had their own code, so it didn't matter which section of that course you're in, you got the same code. It's just you used it for my classroom or you used it for another instructor's class. So that's what they changed. Because they want, I don't know why they decided to do it this way, but if it worked, it would have been fine, but it didn't work because Red Shelf kind of blew up in its own face on the first day of school, which sucks.
Yeah, that does suck, sir. You know, I remember a similar story that I learned in history about the government or whatever. They were providing insurance for everyone through like Obamacare or something, and then everyone tried to go get it, and the server was overwhelmed, and so it blew up in their faces. Is that what we're dealing with Red Shelf as well?
Yeah, they probably, well, no, from my understanding, there was an internal issue. It wasn't that they weren't prepared for the numbers of people. It's just something happened with their hardware and their servers went down, not that they were overwhelmed.
Okay.
So it's kind of the same, but a different, from a different angle. It's from their angle, not from the internet being inundated.
Gotcha. So in any case, I'm not able to do the red access thing. How will I get a code? I did access to the temporary book.
So you're in there, you have temporary access. Okay.
Mhm.
I'm getting my department head. She's the one who gets me my codes that I send to you.
Okay.
And so I'm waiting.
Oh,
I'm
yeah,
waiting
okay.
on her.
Gotcha. And she's on vacation somewhere, like in the Bahamas or something.
No. No,
Hawaii.
I sent her a list of the number of temporaries I have. So you need to have the temporary access before I can send you a code.
Mhm.
So that's
Yeah,
why
I
I'm
just
telling
got it.
everybody you have to get in there. So even if you can't get the code from Red Shelf, you still have to get the temporary access. And I can see who's in there and who has temporary access and who has full access. And so I just count the number of people who don't have full access, and I tell my department head, and then she contacts the bookstore, and the bookstore is the one that provides her with the codes, and she sends them to me.
Gosh, sounds like a lot to do with all these.
Well,
You got to go.
It's
through
a
these different-
bureaucracy, yeah. So,
And the bookshelf, they could be
but
overwhelmed.
she gets back to me pretty quick, like within the same day or two. So, I sent her a list yesterday, and today she sent me codes, and so I don't think she sent me enough codes, and so
Oh.
well, I think she misread my email. But
That's communication, sir.
I'm the one who usually misreads my emails, but okay. So it's very important that you get in there because that's where you do your learning. Learning happens when you're doing the work. Let me do this. There we go. There's my ugly mug.
Yeah. What was up with that other photo with the fedora?
Oh, that was a picture. That's my profile pic for in Zoom. That's all.
I like
yeah?
the fedora, sir. I like the fedora.
Yeah, so do I. My wife doesn't care for it, but she says the brim is too small for my head. But I don't know. I like it. I like hats.
Me too,
Okay.
sir.
So what I'm going to do now is go back to, are there any questions concerning stuff.
Did you know when we're gonna get full access yet or no?
As soon as I get the codes, I email it to you and you use that code to convert your temporary access to full access.
Because you emailed me a code like I think last week. Am I supposed is that like my full access?
Yeah,
code?
that's the one you use. Yeah. You're one of the two people who I sent codes to who haven't used them yet
Okay.
from this class. I have other people in other classes that haven't used them yet either.
Okay, I'll use that one.
So that's the one you use. And you, I don't know how, I've never seen that side of it, so I don't know how you end up using it. So. And gonna, oh, good. Just keep talking to us.
Sir, how is it determined who would be in Zoom and who would be in class? Just curious.
It's what one you, it's which one you signed up for. You go
Yeah, we
into
picked it.
ACES.
We
You
got to
go
pick
into-
it.
Yes,
No, I'm just saying we got to pick. Like it showed you either Zoom or face to face, and when you were signing up for classes, I just picked face to face.
okay. So you go into your ACES account, not Canvas, because everybody in Canvas got put into the, it shows up as section 025, even if you were in 026. Because I combined the two classes so I wouldn't have to post one to one class and then quickly post another one to the other class. So everybody gets the same thing at the same time. So I don't forget. That's a blessing on one side. But in ACES, you're still in the same course, whatever you were in, whatever you signed up for. So you go into your ACES account and look at your course schedule there
Mhm.
and look at what section you're in.
Yes.
If you are in the ACES section is 025, then that means we meet in person. And I can't remember what classroom it is. It's either in San Jacinto or Brazos. I'm pretty sure it's in San Jacinto. And if you're not already on campus, plan on getting on campus a half hour before the class begins, simply because you have to go through the checkpoint to get the little thing, the wristband. And the wristband is a different color for every day. And I say get there a half hour early, mainly because there may be lines. I will get
Okay.
on campus around 7:30 because I have an 8 o'clock class, and I'll stay on campus till after this class is done on Tuesday, Thursdays. And my office hours will be through Zoom. I have an office on campus, but they don't want us to meet with students in our offices because of COVID, which is a good thing. For those of you who come on campus, I highly suggest you wear masks for several reasons. The first of which is I don't want to get COVID and I don't want you to get COVID. So that's a number one way to protect us from that. It's just good pandemic protocol to do that, because we're not out of the woods yet with this sucker. I can't force you to do it, but because of our lovely governor, I'll stay out of politics. Can get me into trouble.
So, sir,
Okay.
if we came to your class without a wristband, would you be like, get out of here?
I say you need to go get a wristband. That I'll put my foot down on. You need to go get a wristband.
Okay.
And you get those either in Ozona, where the library is, or in the Palomino Center. Palomino Center. Palomino Center. You know, which is where a lot of administrative offices are.
Heard. And is it freezing in your class, sir?
I have no clue.
Uh,
I haven't been on campus for 2 years or a year and a half or however long it's been. The spring of 2020 was the last time I was on campus, and that was like at the beginning of March is when we quit being on campus. And so I haven't been on campus since then. Well, I've been on campus, but that's just been this summer. But I don't know how cold they keep the rooms anymore. Yeah.
okay, just curious if I should bring like a hoodie just in case.
Well, if you had to in the past, I'm pretty sure you might have to now, but I'm up in front of the room walking around like a madman, so I get warm. So
Okay, and so the Zoom people, they'll see like the view of you.
yeah, what they've done is they put cameras and microphones in the front of the classroom. And I can set the camera to see the front board, because that's where I work off of, is the front board. And the PowerPoint will be projected on the board, and I'll do all my writing on the board rather than on the tablet like I do over here. Okay.
Yeah, man, I really like the tablet though. It's like just right there, right in front of your face. You can see everything very clearly,
Yeah.
especially when you put it on the YouTube videos.
Okay. But because it's going to be zoomed, it's going to be recorded. And the deal with the camera is if I'm writing too small for someone in Zoom to read, all you have to do is again type in chat, which I need to open up again. Put in chat that you can't read it, or better yet, unmute yourself and tell me you can't read what I wrote, and I'll write bigger. My biggest problem is I start writing smaller because I can write faster if I write smaller.
Yes, I've noticed that, sir. When you write small, sometimes I'm like, I can't read what the heck he just wrote. I'll have to go back and rewatch this.
Well, you can tell me and I'll rewrite it. So it won't
Okay.
offend me, I swear. Okay, so we'll go ahead and get started now. And let me see, I'm gonna back up a second here. Oh yeah, and so we did this rain gutter problem, right? You remember doing the rain gutter problem?
Partially, sir. I was like going downhill on this one.
Oh yeah, it was the end of the class. So what they're talking about is depending upon the angle of that side, whatever angle it's at, changes the volume. And this is the volume, and then this was the formula for that. And so we would put 30 degrees in for theta and calculate it. So 30 sine of 30 was what? Pi over, 1/2, and cosine was a square root of 3/2. And so I add 1 to the square root of 3/2, and I multiply 1/2 by 8 by 16 to get 8, and then I multiply whatever number this is by 8, and then they rounded everything to 2 decimal places. So they go ahead and used 2.14. I mean, 3.14 for pi. Or they use the pi symbol in and so. And got that. And for 30 degrees, it had 14.38 square inches. And that's the opening. So that's just the flat surface. The volume would be how long is the thing. And then for 45 degrees, oh, hit the wrong button. They got 19.31 square inches. So the 30 degrees was a pretty shallow angle. So that would be like that. And then the 45-degree angle would go like that. So that with these two sides being at 45-degree angles to the flat, they create more volume than a 30-degree angle would on either side. Whoops. And my drawing's kind of crappy. But and then you go to the 60-degree angle and it increases the volume even more to 20.8 20.78 square inches. And so if you had so when you think about it, you want your rain gutter to carry more water so it will not overflow. But then you have the issue of the flow rate, depending upon how steep that rain gutter is angled and how fast it drains. So the more water in there, the slower it's going to drain. But anyway. Okay, now we talk about the symmetry that I had spoken about on that. Let me go back to this fun thing. I need to start. I should have done this sooner. And yeah. Where is it? All right, so where I was talking about, when I was doing this the other day, I talked about the symmetry that's created with these. These are the pi over 6 angles, or the 30-degree angles. Whoops. No, these are the 60-degree angles. The pi over 3. And so they have the same coordinates, but with different signs. And what they're showing there is the 45-degree angles, or the pi over 4 angles. And they have the same coordinates. I'm not being able to speak properly right now. I had this past January, I had surgery and got all my teeth replaced.
Sir, I thought your teeth looked different. I was like, this guy's teeth are better and whiter. Sir, I noticed that, and I don't want to say anything, but yeah, they look great, sir.
They're all fake.
They look good, sir.
I have my real teeth. I still have my teeth. They're in a plastic baggie.
That's kind of gross, sir.
About a third of them are rotted away. So yeah. So we have this situation where this is 45 degrees and this is 135 degrees. So this is pi over 4 and this is 3 pi over 4. and then we have 5 pi over 4, and then we have 7 pi over 4, or the 45, 135, and what is this one? 225, 15 squared, and this one is 315.
Okay,
All
so I
right.
see the pattern in 1357. That's nice to see. Within the pies.
Yeah. And yeah, there's patterns all through this. So those will have the same. Oh, that this was supposed to be over here. Put it with the wrong one. Okay. So now I call them the 30-degree angles or the pi over 6 angles. All right. So we have pi over 6, and we have 5 pi over 6. This is one more, 1/6 more than 0, and this is 1/6 less than pi. And this is 1/6 more than pi, which is 7/6, and the one over here is 11/6 pi. And so this is 30 degrees, and this is 150 degrees, and this is 210 degrees. So I wrote 2110. And this one over here is 330 degrees. Right? This is 30 more than 0. This is 30 less than 180. Right? This is 30 more than 180, and this is 30 less than 0, or 2 pi. Okay? Hearing something in the background. Okay. And now and so that was this page, and they talk about finding these angles over here.
Sir, for the one you just did, that rectangle
Yeah.
within the 30-degree angles, is there a pattern like the one for the 45-degree angle?
Yeah. This is 0 plus pi over 6. This one here is pi minus pi over 6. This one here is pi plus pi over 6. So that's 1 more sixth than 1. 1 is 6/6, and so this is 7/6, where this is 5/6.
Yes.
Same
Okay.
thing happens over here with this one. This is 1/6 pi less than 2 pi. 2 pi is 12 pi over 6. So 1/6 less than that is 11 pi.
12 pi over 6. Okay,
Right.
because it's double that. Okay,
Because
gotcha.
it's 2 pi. It's 12 pi over 6, because 12 over 6 is 2.
And sir, what did you call these again? It's like the 0.0 and then the one on the top. It's because
Oh,
I'm seeing,
the quadrantial angles?
yes, that, because I guess the pattern is they are going to be pi over 6 away from those quadrantial angles. Because this one on
Oh,
the right
these here?
side,
Well, these last ones deal with 60 degrees or pi thirds. So those are done similar to the way the 30 degrees ones are. I have 1 more than 0, or I have 60 less than 160. So this is going to be 120, or 2 pi thirds. because I have 1 pi, 2 pi, 1/3 pi, 2/3 pi, 3/3 pi, and this one down here is going to be 4/3 pi. All right. And then the next one is going to be 5/3 pi. And then you're back up to here.
5/3 pi.
And then the next one is going to be 6/3 pi, which is, so 6 pi over 2. So 0 radians is the same as 2 pi, is the same as 12 pi over 6, was the same as 6 pi over 4. And if you take the quarters into play, it's the same as 8 pi over 4. So you have all those relationships going in there, and so you have the you have the ordered pairs that get built up in that way as well.
So many
Okay.
relationships are, it's crazy.
Yeah, well, it's because of the symmetry of a circle. A circle has massive numbers of symmetry, has infinite numbers of symmetry. Because it has symmetry with respect to the y-axis. That's the symmetry going this way with all of these. Okay. And then it has symmetry with respect to the x-axis. So that's this symmetry going this way. And those symmetries deal with the x and y values stay the same except their signs. So you're just dealing with the signs here. If they're connected by a rectangle or a square, technically a square is a rectangle. Then the coordinates, the numbers themselves without the signs are going to be the same. It's just which quadrant you're in. All right, so here I have the first quadrant, so they're both positive. Here I have the second quadrant, so the x is negative and the y is positive. Here I have the third quadrant where they're both negative. And here I have the fourth quadrant where the x value is positive and the y value is negative. And this next slide, not this one, but the one after, and after this, is dealing with these. So when you're given an angle measure, you look to see where does it wind up? Where does its terminal side end up? If it ends up on one of these things, on one of these terminal sides, then the x and y for that point on the unit circle is going to be the same. And so the sine and cosine and tangent and cotangent and cosecant and secant are going to be the same.
Sir, it's the same as the one that they land on, right?
Yeah. So
Okay.
so it doesn't matter if I just go once around to this 45-degree angle, the 3 pi over 4, or if I go around the circle once and then stop there, or if I go around hundreds of times and then wind up, and then I wind up there, the trig functions are all going to have the same value.
Jesus Christ.
Because we're not talking about how many times you make that revolution. We're just talking about where do you end up.
That's funny.
Okay.
It's like wasting all your time. I mean, not wasting all your time. It's like, are you kidding me? I did all this work going around the circle a million times and you're just going to count where I ended up?
Yeah. Let me back up to, well, let me go forward. So let me see, like letter D here. We're trying to find the cosine of 8 pi thirds. Well, 8 pi thirds is greater than 2 pi, right? Because 2 pi is 6 pi thirds, right? Well, so that means I'm doing 6 pi thirds plus 2 pi thirds.
Okay, I see.
So 2 pi thirds, or 135 degrees, and the coordinates of that point are the negative square root of 2 over 2 and the square root of 2 over 2. And so I build the trig functions off of this. And so the cosine is the x value. So the cosine here is the square root of the negative square root of 2 over 2.
Sir, 2 pi thirds, that's 1/2.
No,
That's negative 1/2.
oh, 2 pi thirds is, oh, I was looking at the wrong thing. 2 pi thirds, yeah, is this one. I was thinking, I have the quadrant, I have the 45-degree angles stuck in my head. So this is the same as 120 degrees.
Okay,
Okay,
sir, I got your back.
which is right here. Thank you for telling me that. And the coordinates of that point on the unit circle is a negative 1/2 square root of 3/2.
That's right.
Okay. All right, this one with the negative angle. All right, I'm gonna erase a bunch of this in here because it's gotten too cluttered. All right, so normally when we think 60 degrees, we're going counterclockwise, but negative is going to be going counterclockwise. So this is a negative 60 degrees. So I wind up on this terminal end, which is the same as 5/3 pi or 300 degrees. And
Correct.
and since I'm in the third quadrant, I mean the fourth quadrant, the y value is negative, so sine is going to be negative. And this point here is 1/2 comma negative square root of 3/2.
Yes, sir.
Okay. And tangent of 5 pi over 3, well, that's the same point. And so it's going to be negative because tangent is negative down here. Tangent is negative in all the sine functions are positive in the first quadrant, and the tangent and the tangent is the only trig, well, the tangent and cotangent are the only ones that are positive in the third quadrant. And in the fourth quadrant, only cosine is positive and secant. And in the second quadrant, only sine and cosecant are positive. And I think we talk about that a little bit later.
Sir, tangent of 5 pi over 3. So then that is the y and the x, the y over x, right?
Right, and that's what they have here on the slide. Negative square root of 3 over 2, 1/2.
Yeah. So then that becomes, doesn't that become what was that? 150 degrees?
No, this is 300 degrees.
Okay, sorry, I was reversing the x and the y. Oh, my bad. But you put them over one over the other, not flip them around. Okay,
Yeah,
sorry.
it's y divided by x.
Okay, got you.
And so that gives us a negative 1/3. because the denominators go to 1. So we have the square root of 3 over 1, which is negative square root of 3. All right, and this is just using a calculator. Just make sure you have it in the appropriate mode. Is your mode set for degrees, or is your mode set for, I see this other problem, is it set for radians?
Sir, I need to get a calculator. I've been using my phone and I've been using the online TI calculator.
Okay. Here it is. On what place is that called? The Dollar Tree, I think it is. Yeah, Dollar Tree is where I got this thing. I got this at Dollar Tree. It cost $1.
I know you're always bragging on that calculator, sir.
I tell you what, you could buy 5 of them for $5. So if one of them dies, you got another one right there.
Okay.
It's cheaper to buy a new one than it is to replace the batteries. And to replace the batteries, because I looked into it, you have to, it's got 8 screws on the back, 8 tiny little screws on the back that you have to undo, and you pull it off, and those batteries are spring loaded, so they kind of pop up a little bit. And so it's not the easiest thing to deal with.
Gotcha. I was just gonna like go to Walmart and get one, you know?
Oh yeah, well, yeah, you can get the TI 30A or one of the more expensive models. The TI 30A basic model only costs around $10 or $11. Last time I priced it was $10, but that it may have gone up since then.
Which one would you suggest, sir? Like, I mean,
The TI, because it's a good all-around calculator. You can use it in a lot of things.
uh-huh.
I mean,
Which
you
one,
can,
sir?
if the TI 30A,
Okay.
it's just a basic scientific calculator. You can get a more fancy one. I have a basic one. I have a couple of basic ones, and I also have a couple of them that are solar powered, so they're a little more expensive. And then they have them that are even more expensive and have more bells and whistles, but it has all the same basic functions this one has. All the functions it has are the same. It's just some of the extras that it might have. Like with the memory, it may have extra doodads with the memory, but I don't use any of that. And for my class, you don't need to use any of that, but it might be nice for you to have later on, especially if you end up taking a stats class. You can use this in stats as well.
I swear I had a calculator on here somewhere.
But it's easier to use, and if you have stats, it's easier to use the more expensive calculators. But yeah, I have this exact calculator in my phone. This is a TI-83 silver, TI-84 plus silver edition. I have this exact same calculator in my Android phone, and I think it's available for the Apple phones as well. And it cost me $0.
Yeah. Okay. I remember you talking about that one last time.
Yeah. The only downside is that you have to download a screen for it. And I don't remember how to do that.
Gosh.
Wabbit Mew.
Okay. I can try. I can YouTube it.
Okay. All right. Yeah, all right. When you're using a calculator to use secant, these calculators, these basic scientific calculators, do not have the reciprocal functions. So to do secant and cosecant and cotangent, this is how you do it. You do it 1 over, so secant is 1 over cosine, so it's 1 over the cosine of the angle. So you type in 1, divide by cosine. Be sure you close the parentheses. 21 degrees if you're entering degrees, or you enter in the radians if you're entering radians. If you're entering degrees, you won't need to enter the degree symbol. Calculator won't understand what you're trying to do if you do that. Because it'll automatically assume you're using degrees if it's in mode for degrees. If it's in the mode for radians, then it'll assume you're talking about 21 radians, which is
Okay.
quite large.
Sir, I have one that I bought for your class last time. Can you see it?
Oh, then yeah, use that.
Yes, sir. I never really used it last year, but I'm excited now. It's in degrees, sir. Is that what it's supposed to be in?
Well, there should be a way to change that. There should be mode or something like that on the screen. I mean, in the keyboard.
All right, I'll have to figure it out.
All right. So. Now, here we're talking about with the unit circle, we're dealing with the equation of the circle, which is x squared plus y squared equals 1. Because the radius of the unit circle is 1 unit. So 1 squared is 1. But when you change the radius from 1 to some other number, then we're dealing with these situations. Because if you think about it, sine of theta is y over r, and if r is 1, then you get the unit circle, and so that's why sine is 1. The unit circle is a special case of the circle where the radius is 1, because it simplifies all these formulas. Okay. Now, another way I like to think of these is that this is r sine theta equals y. Cosine theta equals x over r, x divided by r. And another way to think of this is multiplying both sides by r, you get r cosine theta equals x. So if you're given a point, like we're going to come up with another point in on the next slide, for -3. So the y value is 4. I mean, the y value is -3, sorry. -3 equals the sine of whatever the angle is. And I can't see what it's saying the diameter is. I mean, what the radius is. Oh, I moved over too soon. Okay. And so r times sine of theta. But it doesn't. Yeah. Well, we'll look at that more closely when we get to it. Tangent of theta is just y over x. So you don't need to know the radius to figure out what the tangent is. So the tangent of in this case is going to be a -4/3. I mean a -3/4. And then cosecant of theta is r over y. Or there's a couple of ways to look at this, but I like to write it this way: y cosecant theta equals the radius. Or you can say that y equals the radius divided by the cosecant. And secant is the same thing, except it's with cosine. All right, and 1 over cosecant equals sine. So that's going to equal r sine theta. So if we're talking the same point, you're going to get the same y value, whether you put it, whether you're using cosecant or sine. And same thing with cosine. I mean, with secant, it's r over x, which is the reciprocal of the cosine. That doesn't look like cosine to me. And so I like to rewrite this as x secant. I get in a hurry and I write everything wrong. Equals the radius. And then dividing by the secant, you get x equals r over secant of theta. And since secant is 1 over cosine, so this is just the same as r times cosine. Well, it makes sense that we would be talking about the same x value for cosine as we would think of for secant. The x value would be the same for those 2 points, for that point. Okay. And then cotangent is just the reciprocal of tangent. So that's going to be x over theta. I mean, x over y. And with the cotangent and tangent, the denominator cannot be 0. Same thing is true with cosecant and secant. Okay. So we look at this to find these angle measures, or to find the sine, cosine, and whatever. We want to know what the y value, what the x and y. Well, we're given what the x and y value are, but now we need to find out what the radius is, because they don't give us what the radius is. But if you take a minute to think about it, we have a point that is at 1, 2, 3, 4, 1, 2, 3 negative. And so this is the terminal side of that angle. Does that make sense? So we have a circle that kind of goes through like this, that is centered here, and this point is on that circle. Well, this point is 4, -3. What's the distance from here to the origin? That'll give us the radius. That's the length of the radius, is the distance from 0, 0 to 4, -3. If it's centered on 0, 0, then it's just going to be the x value squared plus the y value squared, -3 being squared, and you take the square root of it, that gives you the radius. That's just the distance formula. If it was centered on some other point other than 0, 0, then you would subtract the x values and you'd subtract the y values, and then you'd square those. And that's using the distance formula. And so 4 squared is 16, -3 squared is 9. And so 16 plus 9 is 25. So that's the square root of 25. So the radius is 5. So this distance here is 5. Sine is the y value divided by the radius. So the sine of theta, and notice they didn't tell us what theta is. We don't need to know what theta is in this case to know that the sine of that angle is a -3/4. And the cosine is going to be x over the radius. And so that's going to be, oh, I wrote a 4 there. That should have been 4/5. Did someone notice I used the wrong number? Is going to be 4/5. And tangent is these two values in a fraction. So the -3/5 divided by 4/5, this gives us a -3/4. I know I wrote kind of small there. Okay, next thing. Oops. I think there's a way to change that. All right. And now cosecant, rather than using this, well, this formula is the reciprocal of this formula. And so that's going to be the reciprocal of -3/5, which is a -5/3. Secant is the reciprocal of the x value. The x value is 4/5, so the reciprocal is 5/4. And cotangent is the reciprocal of tangent. Tangent is a -3/4, so this is going to be a -4/3. So here I have the 6 trig functions for that point. All right, and so yeah, so they went and found the radius and got the 5. When the center is at the origin, that's how you calculate it. The center was someplace else, then you do something first before you use the full distance formula. All right, and now we have x is 4, y is -3, and r is 5. So you just put those in the function in the formula. So we know what those are without calculating, without knowing what theta is. Now there's a way to find out what theta is by using a function called arctangent or the arc trig functions or the inverse trig functions. And on the calculators, you will have those. And if you look above the sine function and the cosine and tangent, they have it written like sine raised to the -1. Well, it's not sine raised to the -1. That's the inverse of sine. So if I did sine inverse of a -3/5, that'll tell me what the angle is. If I do the inverse cosine of 4/5, that'll give me the same angle. If I do sine inverse, the inverse tangent of a -4/3, it also will give me the same angle. Now the calculator might give you a negative angle because of where it is. Well, if it gives you a negative angle, you just either add that to 360, so you're subtracting, or to pi over to 2 pi if you're using radians. Okay. Now we're going to talk about some of the properties of the trig functions. We're going to determine domain range of the trig functions. We're going to determine period of the trig functions. Trig functions repeat their y values. Your y values will repeat themselves. So we look at full circle. Full circle, that's a period. Okay. And so when graphing it, we look at what happens with that period. So if and that period can change depending upon the frequency. So with electronics, I think you understand what I mean. And then we're going to determine the signs of trigonometric functions given its quadrant, and I already kind of discussed that a little bit. And then find values of the trig functions using the fundamental identities. And find exact values of trigonometric functions of an angle given one of the functions and the quadrantial angle. And then use even odd properties to find the exact values of trig functions. All right, trig functions, if you remember from college algebra, functions can be even or odd or neither. Okay, and so those properties hold. Well, trig functions are either even or odd. Well, I better not say that. The basic trig functions are either even or odd. They either have symmetry with respect to the y-axis, or they have symmetry with respect to the origin. Right? If you notice with the unit circle, I'm not going to open up that one. So I have a circle, and it's a unit circle. If we have an angle that's in the first quadrant and an angle that's in the second quadrant, the x values will be the same, will be the opposite sign. The y values will be exactly the same, but the x values will be opposite signs. That shows symmetry with respect to the y-axis. And then and same thing is true with the third quadrant and the fourth quadrant. The second and third quadrant, all the values are the same except the y values change their sign. Same thing with the first and fourth quadrants. The X values remain the same, but the Y values just change their sign.
Yeah.
So that shows symmetry with respect to the X axis. Now, the first and third quadrant shows symmetry with respect to the origin.
Mhm.
The signs change.
Yes.
This angle up here, this point up here, and its corresponding point down here, the X and Y values just change their signs.
From positive to negative.
Right. And same thing with the first and the fourth quadrants. This point here and its corresponding point on the other side. The only difference between the two is that the X became negative and the Y became positive, or vice versa, depending upon which direction you're traveling. Okay. So let theta be an angle in standard position. Let point XY be a point on the unit circle that corresponds to the angle. And so, yeah, we have this. We've already been discussing that. So they're just setting it up. So the domain of the sine function is a set of all real numbers. I can put any number in for sine because I can go in the positive direction as many times as I want. So I can use any number from 0 to infinity. But I can also go in the opposite direction. I can go from 0 and go that direction. So I can go in the negative direction. I can go to negative infinity. So that's all real numbers. So the domain is all real numbers. Same is true with cosine. With sine and cosine, you get all real numbers for the domain. Now, the domain for tangent you have to exclude certain numbers because sometimes the X in the denominator is 0, right? Because sometimes you wind up on the X-axis, and when you wind up on the Y-axis, my apologies. When you wind up on the Y-axis, sometimes that means the X value is 0. So the odd multiples of pi over 2 or 90 are excluded. So it's all real numbers except for the odd multiples of pi over 2 or the odd multiples of 90. So that's 1 times, 3 times, 5 times, 7 times, and the negative as well that you're going to exclude from the domain. Same thing is true with secant, except where does cosine equal 0? Cosine equals 0 up here and down here. So the domain of secant is the same as the domain of tangent because I can't use the cosine value because it's 0. And with cotangent and secant, the same thing happens, but it's going to be odd multiples of pi.
Hey, sir, what was the third one after tangent?
Cosecant.
Cosecant.
Secant.
Oh, secant.
Secant.
Thank you.
Because when the cosine is 0 or the X value is 0, then secant does not exist. because you get 0 in the denominator. It's undefined. But when we're dealing with functions, we more accurately say it does not exist at that value because we have a vertical asymptote at that value.
Yes, that would be a black dot, right?
Uh-uh,
An open one?
open.
Open, okay. Sorry, I'm just,
Actually, when you graph these things, you're going to have a series of vertical lines that are asymptotes where the function does not exist, and so it's going to come up and each of these little parts here look exactly the same. But now for cotangent and secant, actually it's the integer multiples of pi, because at 0 pi the y value is 0, at pi the y value is 0, at 2 pi the y value is 0, at 3 pi the y value is 0. So it's not this is it's an integer multiple of pi, not just an odd multiple of pi, right? Because my point here is 1, 0, and x over y, which is cotangent, is 1 over 0, which is undefined. So that means the function does not exist at 0 radians.
oh, so
or
sir,
0 degrees.
you're contradicting what the slide says?
Well, I'm saying they're wrong.
Okay,
It's not odd.
gotcha. It's not just the odds, it's all the integer multiples of pi for cotangent and for secant.
Right.
Okay,
That don't exist because you have this situation where these vertical asymptotes are multiples of pi. Okay. Now the range, realizing we're dealing with the radius of 1, the range is from -1 to +1. For sine, all the sine values are the y values from -1 to +1, because along this circle, the highest y value is +1 and the lowest y value is -1. So the range is a closed set of numbers from -1 to +1. Same thing is true with cosine, because the x values, the largest x value is 1 and the smallest x value is -1. And so every x value of the points on this circle go from -1 to 1. So sine, the theta is all real numbers,
the
but the
domain.
y values you get are only from -1 to 1. This is what we call, it's a cyclical function because the y values keep repeating over and over again. And it's called sinusoidal. The cosine and sine functions are called sinusoidal because they follow, they look like, they go like this.
Sir, is that because they go up and down only to negative, positive, and I
Right.
mean -1 and +1?
So yeah, this would be a +1 and this would be -1, Now, if sine was being multiplied by something and cosine by the same thing, then the -1 and +1 would go higher and lower or closer to that would change. But as soon as your radius changes, then these high and low numbers change. So if I had a radius of 3, then the highest number would be 3 and the lowest number would be -3. So both of these would be from -3 to +3. So it all depends upon the radius, but since we're talking about the radius of 1, then that's what it is.
Yes, and we've been dealing with the radius of 1 this whole time, right? Like we haven't changed it really.
No. And when we start changing radius, it's just when we're talking about the functions, not the circles. So the function is different. When we're talking about functions, we're not looking at the unit circle anymore. We can use the unit circle, but we're not dealing with the unit circle directly. Okay. With cosecant, you end up getting numbers that are less than or equal to -1, or you get numbers that are greater than or equal to +1. With cosecant, your graph really looks different. I'm going to put in these lines here. And this is just going to be a generic look at what it's going to look like. And so if this is 1 and this is -1, then you're going to have this situation happening. Your graph is going to look like this. And actually this will hit -1. So I missed it a little bit there. Same thing up here. I missed it just a little bit. So that's what secant will look, cosecant and secant will look like that. Where secant, it's every other one is up and down. Same thing with secant, but where cosecant goes down, secant goes up. And where cosecant goes up, secant goes down. So, or it's just shifted a little bit. I think it's more about that it's shifted, not that it's oh yeah, it's shifted where this, whoops, now this point is on this line, and where that point was is where the asymptote is for the other one. So they're just shifted. That's what happens there. And so for secant, you have the same domain, the same range for secant that you had for cosecant. And for tangent and cotangent, it covers all the y values. Even though there are certain x values you can't use, you will cover all the y values again and again, because it's repeating, it's periodic, it's cyclical. And tangent function, the graph of tangent function kind of looks a little bit like the cubic function. And then the secant function, the cotangent, I'm trying to remember, does it go the opposite direction? Or I can't recall right off the top of my head right now. That's the one I'm fuzzy at. So you have a bunch of these just right next to each other where they go up and they go down. But these are just repeated again and again and again and again. Going to the right and to the left. Just like these are repeated again and again, going larger and going smaller. All right. Sine, the symbol is sine theta. The domain is all real numbers. The range is all real numbers from -1 to 1 inclusive. Same thing is true with cosine. Tangent, it's all real numbers except for the odd integers of pi over 2. And the range is all real numbers. Cosecant is all real numbers except for integer. See, here they got it right. Here they got it right. Integer multiples. On that previous slide, they said odd multiples where I said it was wrong. Okay, so yeah, the editor, that's a case where the editor and the writer and the creator of the PowerPoint didn't talk to each other. You'll hear me bitch and moan about them all the time. Okay. And then secant is the same as tangent. And cotangent is the same as cosecant, except for the range. The ranges are different. The ranges are the same on tangent and cotangent, and the ranges are the same for cosecant and secant. So those relationships there are somewhat symmetrical, but not totally the same. Okay. And you have access to this PowerPoint, so you can pull that slide up and print this page up if you want to put it in your notes. Or copy it down into your notes. Okay. All right, and we've been discussing this already. Theta is considered, well, not exactly the reference angle, but it is an angle that we reference. So that's where I was talking about how many times you go around the circle before you get to that angle is not as important as what that terminal side winds up. And so what's the angle between 0 and 2 pi? That's the same angle as this terminal side. Okay. So whatever the angle is of this terminal side from the 0 degrees to that terminal side, that's the function. That is for any function where k is an integer. And the funny thing is, it's true for all 6 of the trig functions. All right. Periodic function and fundamental period. A function is called periodic as there is a positive number p with a property that whenever theta is in the domain of f, so is theta plus p, and f of theta plus p equals f of theta. And y'all are going, what the fuck?
Ah, thank you, sir. I didn't want to say
Okay.
it. I didn't want to say it, but you said it, so thank you.
Okay, so what? All right. So let's look at the angle. No, not 6. Let's go with 7/2 pi. Seven halves pi. So 7/2 is 4/2 pi plus 3/2 pi, right? It's because I look at what's a full revolution of the circle. Well, that's 2 pi, so that's 4 pi over 2. That's the same as 2 pi. And then when I add 3 more pi halves to it, gives me the 7 pi. So this angle goes around the circle exactly once and then goes 3/4 of the way again. So it winds up here. Well, that angle is 3/4 pi.
270. Gotcha.
So this is 3/4 pi plus 2 pi. And that's where k equals 1. So that means this p value is 2 pi. So p is the period. If there is a smallest such number p, then the smallest value is called the fundamental period or the period of pi.
Sir, where did you get the 3 pi over 4?
Well, once around the circle is 4 pi over 2,
Huh?
right? Because
Yes, sir. That's 2 pi.
that's 2 pi,
Gotcha.
but I'm dividing by 2. So that's what I wanted to do there. So 4 pi over 2 is less than 7 pi over 2. So I have to add 3 more pi over 2 to get to 7 pi.
Yes, sir.
So the 2 pi takes me once around. So that's this part. And so that's what's that left is this.
I understand. Yes, sir. What
So
I'm
that's-
curious about is the 3
that's why-
pi over 4.
Where do I have 3 pi over 4? Oh. That wasn't supposed to be there.
Okay, thank you, sir.
Thank you. So what if I had 17 pi over 3? Since my denominator is 3, 2 pi would be 6 pi over 3.
Nice.
And going around the circle twice. So if I multiply this by 2, that would give me 12 pi over 3. If I multiply by 3, that would give me 18 pi over 3. So this is between these two numbers.
Yes.
So that means it's going to be 12 pi over 3 plus how many pi over 3 to get to 17 pi? Well,
5 pi.
Yeah, 5. So 5 pi over 3, which is in this quadrant right here. So you wind up going around twice before you come here. which is the same as just going once to that side. And my K value in this case is 2 because I'm multiplying 2 by pi by 2. And my period is still pi over 2. I mean 2 pi, excuse me.
K is 2 for this one. Got you. Okay.
So the period is 2 pi because that's the smallest. That's once around. So
Mhm.
that's the smallest value that makes us keep coming back to the same point, same place on the circle. So that's why it's called periodic, because all my every angle that winds up here on this terminal side will have the same trig function values. Periodic properties.
Sir, is there writing lower or is this all of it?
No, there's nothing down here.
Okay. So for the first equation, K was 1. For the second equation, K is 2.
Right, because I had to
Okay.
go around twice before I wound up to the terminal side.
Okay. So the equation to hit that 300 degrees, that 300 degree marker would be K, would be 2. And then what's the rest of the equation?
Tell me again.
Oh, well, the K1's for the first one, but for the second one, K is 2. So what would the equation look like to hit that marker, that 300
Well,
degree?
the period
Mhm.
times K plus theta. So whatever the period is, and for sine or cosine, that period is going to be 2 pi.
Okay. So that's for the second one, yes? Oh yeah, because 2 pi is a circle and K is 2 times around, so it's 2 revolutions, and then theta will
Right.
be your angle, and theta will.
So yeah,
Gotcha.
all right. So that becomes the 5 pi thirds plus 2 pi times 2.
That's what I wanted, sir.
Okay. I finally understood what you were asking.
Yes, because it's 2 times around, and then we hit that 5 pi thirds angle. Gotcha.
Okay. Now, something to be concerned about or to understand is that different trig functions have different periods. Now, sine, cosine, cosecant, and secant all have the same period, 2 pi. But tangent and cotangent have different periods. They have a period of pi. Because if you look on the unit circle, the tangent values in the first quadrant are exactly the same as the tangent values in the third quadrant. So that's only 1 pi away. And same thing is true with cotangent. And so that's why the period there is only pi.
Are you writing, sir?
No.
Okay.
So we have these periodic properties where the period for sine and cosine is 2 pi. And the period for cosecant and secant is 2 pi. And the periodic period, period for tangent and cotangent is just pi.
Gotcha.
And the reason we say that, well, no, we'll look at it when we start graphing these silly things. Okay, find the exact value. So 14 pi over 4, I want to find out what well, I know the period is 2 pi. So we're dealing with pi over 4. And so that's going to be 8 pi over 4, or 16 pi over 4. And 16 pi over 4 is just under this. So if I add 1 pi over 4, that will give me the 17 pi over 4. So I start, first of all, I change my 2 pi into having the same denominator. So that's going to be 8/4 pi. And then I start doing multiples, so until I get to just under or just above the angle they're talking about. Well, I know 16 is 1 less than 17, so I'm as far as I can go. So that's 8. Wait. 2 times 8 pi over 4, which is 2 times 2 pi. So that means I go around the circle twice before I wind up at that angle. So the sine of 17 pi over 4 equals the sine of pi over 4 plus 2 times 2 pi, 2 times the period, which is the same as the sine of pi over 4, which is the square root of 2 over 2. With letter B, we're going to do the same thing, except 5 pi, the period is 2 pi, and so the next one is 4. And since I'm dealing with integer values for the pi, then 4 pi is 1 less than that, so I'm just going to add pi to 4 pi. So this becomes the cosine of pi plus 2 times 2 pi, which is the same thing as the cosine of pi, which is -1.
Sir, we're approaching the end of class. Actually, wait, hold up.
Yeah, we're a minute past.
41.
We're a minute past. And so tangent of 4/5 pi. Okay, this is where it gets, because this is less than 2 pi. The tangent, I want to do this last one, and then I'm going to call it quits. So we have the period for tangent is pi. And so that's going to be 4 pi over 4, because I want it in the same denominator, which is just 1 less than this. So if I add pi over 4 to it, so this is going to be pi over 4 plus pi. So I'm going to take the tangent of that, which is the same thing as the tangent of pi over 4. And the tangent of pi over 4 is 1. Now, this angle this angle is in the the third quadrant, and tangent is positive in the third quadrant. Okay, so we're almost 3 minutes over. So,
Yes, pi over 4.
unless,
It's the
unless you
the
have
first
questions
quadrant,
for
right?
me, we're done. Yes, sir.
Yeah, that was it, right?
Yep.
Okay. I think earlier someone was concerned with the recording, sir, on YouTube, and like how we can get to them.
Oh, go.
Right now, you only have one. You have the first one up, sir. You don't have I think you only have the 24th uploaded. You don't have the 26th or the 31st.
Oh, I thought I had the first week loaded up. It's just this week I don't have up
On
yet.
the YouTube channel that you provided, we only have August 24th up as something we can.
Oh,
I haven't seen Thursdays or Tuesdays, or this Tuesday, I mean.
all right. Let me check real quick, see what's going on there. Because yeah, I meant to put up Tuesdays yesterday, but something got in the way and I could not do that. So, well, that's not working. It's supposed to be working. Why won't it work? So I'm gonna have to do it. Okay. So the link it doesn't seem to be working that I posted.
No, the link you sent, it had that little studio. If you take that little studio part of it, the link works. That's what I did.
Nice.
Do what? Take the
It says studio
part
at the
away?
beginning of it. Yeah, like I took that studio part out of it and it was able to let me access the YouTube channel. That word that says studio
Oh,
at the
wow.
beginning
Yeah,
of
I
the link.
see that. Okay. So what I'm doing right now is I'm editing that. If it will come up. So I'm going to edit that part out of it. So the link in the link in the announcements will work, which is what I want to have happen. And so I'm going to have to go change that on all of them. Let me see. It's still not doing it. Why not? Oh. Let me see. Yeah, I'm just troubleshooting here. Oh, I see. Yeah, because it's in my cache, it still wants to put the studio in front of it. So it's in my history that way. So let me see.
I'm sorry, sir. The 24th is what I meant. The 24th is the only one.
Yeah.
That's not.
Yeah, that's all that's showing. Well, it shouldn't be. All right. So I'm going to have to fix that. So yeah, if you go ahead and subscribe to it, then you will be able to
Post notifications.
you'll get notified when
Right
I get
hand
it
bell.
posted.
I get you, sir.
And let me see. It's
Channel
not.
that subscriber
It's
count
not.
out.
Sir, you gotta take more content. We want to see more Reed. We want to see what Reed does outside of math class.
Yeah, sir. Come on. We'll subscribe and hit that notification bell. We'll do it.
Okay. Well, Yeah. Well, I access it differently. Because I go through my studio, YouTube studio, to access this. And I thought I could have sworn I'd put stuff up. I did put them up. I don't know why they haven't been published.
Hmm. Yeah, I have 2 videos here, both from fall 2021.
Uh, do you, well, when I upload these things, I'm asked, is it made for kids or is it not made for kids? And I say it's not made for kids simply because I cuss.
Hardly, sir. Come on.
Well, I don't cuss near as much as I used to, but
Sir, the kids, they're exposed to so much more nowadays. They need
I
to get
know.
over it.
The worst I do is use the word fuck.
Oh, no.
But yeah. Um, hmm. Okay. So that, so it only, it's only if it has an age restriction does it block people from viewing it. So I don't see why there's an issue with it. Visibility, it has visibility. Edit, share, get shareable link, promote, downloads, leak for, let me get shareable link for that one. Copy to the clipboard. And we do this. That should be for the 25th. And if I have to start posting these in does that link work?
Yes. It brought me to a video on August 25th.
Yeah. And this one?
This one brought me to an August 30th video.
Yeah. So I have the 3 of them there that evidently.
Oh, sir, this isn't a different, this says pre-calculus, not algebra. Wait, what? I'm sorry. I was in your algebra one. This says pre-calculus.
Yeah.
Okay.
So
What?
yeah, that was math 1414 029.
Okay, that's my bad.
This is math 2412 0025/0026.
Sir, you put the link to the algebra one.
Oh wow.
Sir, come on.
Let me see this. Oh, you know what's going on?
No, no idea.
Is I tried to leave you everything off of that channel. And so this is supposed to be, let me see here. There's got to be a way. Well,
Okay,
that was the wrong thing to do. Hmm.
All right, sir, I'm taking off. You have a good day, and I'll see you next Tuesday.
Okay, bye. Have to figure some things out. I may end up just, I'll create a discussion and put them in there, and everybody's gone, so I'm gonna go away too. So what's up? You're gone.